Hi dear students, we are going to discuss how to identify hard water and soft water of unit number 1 water technology. So dear students, water that gives lather or foam with soap easily, that water is known as a soft water. Okay, means the water which produce foam rapidly, easily. Okay, that water is known as a soft water. Now, what about hard water? The water which produce curd like insoluble material, or you can say scum. Insoluble material is in the form of what? Precipitate. Without producing foam, it produces scum like material, or you can say PPT, right? Then that water is a hard water. So for that purpose, what you have to do? You have to do treatment of water with soap. So the water which produce foam with soap quickly, that water is soft, and the water which does not produce foam with soap, that water is known as a hard water. Now we will see hardness of water. What is meant by hardness and how water become hard, that we are going to discuss. Now here hardness because of presence of dissolved salts, either in less amount or in more amount. But here hardness is due to presence of dissolved, or you can say soluble salts. Now concentration of salts will be less or will be more. So concentration doesn't matter. If salt is present in water, then that water will become a hard. Now as we know, the common salts, that is what the NaCl, KCl, they are not problematic to the industry, as NaCl and KCl not responsible for making water hard. So here I mean to say that if water containing NaCl or KCl, you can use that water directly for industrial purposes like production of steam, or you can say it is used as a coolant to control the temperature of reaction. So here we will see the salts that responsible to make water hard. So in that, salt like carbonates, bicarbonates, sulfate, nitrate, chloride salts, right? So these are the salts of which type of cations? Bivalent cations. And here in bivalent cations, mostly cations like Mg2 plus, iron 2 plus, manganese 2 plus, calcium 2 plus. So these are the salts present in the water, and that salts responsible to make water hard. So Mg2 plus, you can say magnesium carbonate, magnesium bicarbonate, magnesium sulfate, magnesium nitrate, magnesium chloride. Likewise for Fe2 plus, right? So these responsible to give hardness to the water. And if these type of salts present in the water, then it is necessary to remove them before its use in the industry. Okay, so here we can say that the hardness of water, who responsible for that hardness? Dissolved salts of heavy metals responsible to make water hard. So here these are the metal cations, that is what the heavy metal cations produced by the salts, and out of that Mg2 plus and Ca2 plus present in large amount. Okay, so mostly which type of metal cations responsible to make water hard? Mg2 plus and Ca2 plus, because these type of cations present in large amount. Now here, naturally or originally water is not hard, because of some changes, because of some chemical processes, because of some reactions, that soft water convert into hard water. So in that first cause we will see, that cause is dissolution of minerals, second one action of CO2, and third one is action of O2. So these are the three main causes that responsible to make water hard. Now first we will see dissolution of mineral. So how minerals getting dissolved in water? Dear students, rainwater start its journey from cloud. That time that water is 100% pure without any hardness. But the time when that rainwater fall on the ground, on the surface, it percolates deep down in the soil. So it enter in the soil, and as you know very well that in the soil various salts present. So that salts coming in contact with the water, and that salts gets dissolved in it, and that dissolved salts, that dissolved minerals responsible to make water hard. Then action of CO2. How this action take place? So the time the water molecules, or you can say the droplets of water, moving from cloud toward the ground, toward the surface of soil, in atmosphere it coming in contact with the CO2, as you know very well that CO2 present in the atmosphere. So that CO2 react with H2O and it produces carbonic acid. So this reaction taking place in the environment, the time when water droplets moving toward the ground. So that carbonic acid, so in reality H2 is not falling on the ground, carbonic acid is fall on the ground and it percolate in the soil, and once that carbonic acid enter in the soil, it come in contact with the salts. For example, magnesium carbonate is there in the soil, so that magnesium carbonate react with carbonic acid and it produces magnesium bicarbonate. Okay, so this magnesium carbonate is soluble in water, so that in magnesium carbonate Mg2 plus is responsible to make water hard. Then action of O2. How? So here, during the journey of water droplets from the cloud to the surface of ground, everywhere you know oxygen is present in large amount. So H2O is coming in contact with the oxygen, so that H2O become oxygenated H2O, and such oxygenated water enter in the soil. It come in contact with salt like iron sulfide, FeS2, right? And that iron sulfide enter in oxygenated water and it produce iron sulfate. So produced iron sulfate is a soluble, right? And that iron sulfate produce Fe2 plus ions in the water, and that Fe2 plus responsible to make water hard. So if you see this picture, you will get clear cut idea that the first conical with complete turbid solution, or you can say scum like or curd like material, so that is what the hard water. And in second conical you can see that the very nice foam, or you can say lather getting produced at the surface of water. So that foam is the indication of type of water. As you know that water having a two types, one is a hard and second one is soft. Okay, so foam is there at the surface of water is the indication of presence of soft water. So here we are going to discuss types of hardness. As you know that water having a two types, soft and hard. Now we are going to discuss types of hardness. So under that, first type is temporary hardness, or you can say carbonate type of hardness. So what is meant by carbonate type of hardness, and why temporary alternatively called as carbonate type of hardness? Because simply carbonates, that is what the soluble carbonates and bicarbonates present in the water, and that soluble carbonates and bicarbonates responsible to make water hard. But what kind of hardness? Temporary hardness. So dear students, keep in mind, if soluble carbonates and bicarbonates, only two things you keep in mind: soluble carbonates and second one soluble bicarbonates. If present in water, then that water is temporary hard. And as I said, that mostly calcium and magnesium cations present in the water. So here examples: magnesium carbonate, iron carbonate, magnesium bicarbonate, calcium bicarbonate. So here calcium carbonate example is not there because calcium carbonate practically insoluble in water. And as I said very clearly in the definition itself, that we required carbonates and bicarbonates. What kind of carbonates and bicarbonates? Soluble. And calcium carbonate is not soluble. That's why calcium carbonate example is not here. Alright. Then how to remove temporary hardness? So temporary hardness we can remove on boiling. So you just boil the water sample. On boiling, what will happen? Soluble bicarbonates convert into, you just see the first example, calcium bicarbonate is a soluble in water, so it convert into calcium carbonate, and that downward arrow clear cut indication of produced calcium carbonate is insoluble, so it produces PPT. So produced PPT we can remove easily by filtration. Second reaction, we can see that magnesium bicarbonate, and in hurry student write product magnesium carbonate, right, by taking a reference of first reaction as calcium bicarbonate produce calcium carbonate. So likewise magnesium bicarbonate will produce magnesium carbonate, but it's not like that because magnesium carbonate is a soluble, that's why it's not getting produced. So what getting produced? Magnesium bicarbonate produce magnesium hydroxide, and that produced magnesium hydroxide is insoluble, and that insoluble form, that is what the PPT, we can remove it by filtration. Then we are going to discuss second type, permanent and permanent hardness is also known as non-carbonate hardness. Now non-carbonate hardness means what? Absence of carbonates. Then who is responsible to make water hard? So here presence of salts. What kind of salts? Heavy metals, but other than carbonates and bicarbonates. So permanent hardness is due to presence of salts of heavy metals, but specifically you keep in mind salts of heavy metals of what? Other than carbonates and bicarbonates. Other than means carbonate, bicarbonates not responsible for permanent, right? Other salts are responsible for making water permanently hard. So what are the examples? Magnesium chloride, calcium chloride, iron chloride, magnesium sulfate, calcium sulfate, iron nitrite, right, calcium nitrite, or you can say iron sulfate, right? So these are the salts that are responsible to make water permanent hard. So here simple difference you keep in mind. Temporary hardness means carbonate type of hardness, and carbonate type of hardness means carbonate is responsible to make water temporary hard. And permanent, that is what? The permanent, that is what? The non-carbonate means carbonates are not there. Then who is there? Salts of heavy metals like chlorides, sulfates, nitrates. Then how to remove permanent hardness? So permanent hardness we can remove by using some methods. So in that, first one is a zeolite method. In detail we will see later on, right? Then ion exchange method, that is called as the demineralization, both kinds of ions getting removed. Third one is the reverse osmosis, that is what? The RO. And fourth one is electrodialysis. So by using these four methods we can remove hardness. Which kind of hardness? Permanent hardness of water sample. Hope you understood Thanks for watching. Kindly like and subscribe the channel.